So here we have team LTRC-SPL. Let's know about their idea of hackathon.
Hi, I'm Vinay, working as a ML engineer in Ogo Analytics.
Hi, I'm Anindita. I'm a PhD scholar in IIIT Hyderabad, and we are here to present our work on behalf of Team LTRC-SPL. And we have used a TTS model called IMS token TTS and fine-tuned that model with the provided datasets from this challenge. And we have built it for 11 languages: English, Hindi, Gujarati, Bengali, Bhojpuri, Chhattisgarhi, Kannada, Magahi, Maithili, and Telugu. So the main idea of our work was to fine-tune an existing model. So we selected IMS token TTS, which supports around 7,000 languages across the world, and it uses a meta-learning approach where it can learn embeddings from for an unseen language with the help of the learning from already labeled or high resource languages. So it supports 7,000 languages and it included all these 11 languages. So on top of the pre-trained model, we selected to take a subset of the dataset that was provided to us. So we had 35 domains and 11 languages, and the purpose of this model would be to deploy in a healthcare purpose, and in that case we selected domains like food, health, social, agriculture, and also we selected a multi-speaker dataset from Indic TTS and Indic Voices to support the voice cloning purpose, as in it should be trained on multiple languages and multiple speakers, and it should be able to clone new speakers' voices. So this is the total data sets that we have used out of the provided data. It's around 600 plus hours of all the 11 languages, and I request Vinay, you can now explain the training.
So we have used 600 hours of data. It took around 90 hours to complete the training. And if you see the evaluation metrics, so we have evaluated our system on mean opinion score, speaker similarity, real-time factor, word error rate, and character error rate. So we were able to achieve a good mean opinion score of around 4.5 for Hindi and 4.3 for Telugu out of 5. And if you see one of the major thing was to make it to work in real time. So we got a real time factor of 0.5 on an average, which means if you want to generate a 1 minute audio, it takes just 30 seconds to generate that particular audio. Oh, thank you.
It was nice knowing about your ideas. Any questions?
So, what was the size of the model?
So the total size of this model is around 400 MB. So the main TTS model is 201 MB, and the vocoder takes around 125 MB. And to generate the speaker embeddings for voice cloning, it takes around 83 MB. So I think if you compare with the latest models, this is one of the model which has very less size, can be used in real-time applications, real-time deployments. Yeah.
How much time will it take to train this?
So for model training, it took around 4 days. Around 4 days, but 90 hours. And to implement this whole thing, it took us around like 1.5 months. I mean, to understand the system, gather the data, download the data, pre-process it, and to fine-tune it and to test it, it took around 1.5 months.
What was the most challenging thing you faced while working on the pipeline?
Yeah. So one thing was, frankly, the computational resources which we don't have access to. But so that was one major thing. And the second was, while working with languages like low resource languages like Magahi, Chhattisgarhi, Bhojpuri, the accuracy was not that good. So we tried using different methods to overcome that.
So this was all about Team LTRC, SPL. Let's look into another teams.